Okay. Buongiorno, I'm Anton, I'm from Israel, and I'm a computer engineering student here in Politecnico di Torino.
Hey, I'm Daniele and I'm from Padua, and I'm also a computer engineering student here in Turin.
As part of the computer architecture course of year 2013-2014, led by Professor Sterpone and Professor Montuschi, we were presented with an opportunity to experience with actual embedded systems and computer architecture and create a calculator using the Coolrunner 2 board and Xilinx development software.
The Coolrunner 2 boards comes with a 4 digits 7-segment display, 4 LEDs, 2 switches, 2 buttons and an additional LCD display with 2 lines of 16 digits. It has a clock with different frequencies from 10K to 1 MHz, and in our setup we chose to view the operands in the 7-segment display and the result on the LCD. The left switch decides whether we are in operand mode or in answer mode. Instead, the right switch selects if we are in operand mode which operand we are changing. Otherwise, if we are in answer mode, it selects which is the function to compute. To insert the 2 operands, we have to use the buttons, and for example, to compute the multiplication of 2 operands, we have to insert them in the 7-segment display with a hexadecimal representation. For example, if we want to insert the number 26, which in hexadecimal is 1A, we go with the left button to the digit we want to change, and with the right button we increment it. Here is 1A, that is 26, and then with the right switch we go to operand B, which is written in the LCD, and we can put 2D, that is number 45. To get the result of the operation, we just change the switch, the left switch, and we get the multiplication, that is 0492, that in decimal is 1170, which is the correct result. Compute the sign function. Let's first reset the 2 operands, and to do so we go back into the operand mode, and changing the LED, switching all of them on, and pressing then the right switch, we are able to reset the two numbers. Let's compute the sign of 30, which in hexadecimal representation is 1E. So let's change the 2 digits, the second to 1 and the first one to E. And then going to answer mode and then to sign, we get 0050, which is 1/2 without a decimal point. As we said before, the sign function goes only on a specific range, which is from 0 to pi/4, and if we go out of range, for example, instead of 45 we put another number, it shows an error message.
Doing this assignment, we faced many difficulties and many challenges, the first of which was to connect the board to the computer and make the computer recognize the board so we are able to work with it. The next big challenge was to figure out the VHDL language and how to work with the Xilinx environment. Then after we were able to understand all of this and actually program the board to do the calculation we wanted, we faced the big challenge of lack of memory, which apparently the board had only barely enough memory to face what we required it to. To bypass all of these problems, we needed to do what engineers normally do, and to cut obsolete things like extra values of the sign that we didn't need, and extra letters on the LCD display that we didn't need, and to use functions of calculation as small as we can, and to use as less functions as possible.
Yeah. That's it.
And then we can say shalom and ciao. No?
Yeah.
So, shalom.
Ciao.